orchestra. An orchestra also has a conductor to direct the flow of the music. In a computer, the OS is the conductor. The OS handles resource and memory management to ensure the limited capacity of the computer system is used where it's needed most. A variety of programs, tasks, and processes are constantly competing for the resources of the central processing unit, or CPU. They all have their own reasons why they need memory, storage, and input-output bandwidth. The OS is responsible for ensuring that each program is allocating and deallocating resources. All this occurs in your computer at the same time so that your system functions efficiently. Much of this is hidden from you as a user. For example, your browser's task manager will list all of the tasks that are being processed, along with their memory and CPU usage. As an analyst, it's helpful to know where a system's resources are used. Understanding usage of resources can help you respond to an incident and troubleshoot applications in the system. For example, if a computer is running slowly, an analyst might discover it's allocating resources to malware. A basic understanding of how operating systems work will help you better understand the security skills you will learn later in this program. Now that you've learned the inner workings of computers, let's discuss how users and operating systems communicate with each other. So far, you've learned that a computer has an operating system, hardware, and applications. Remember, the operating system communicates with the hardware to execute tasks. In this video, you'll learn how the user, that's you, interacts with the operating system in order to send tasks to the hardware. The user communicates with the operating system via an interface. A user interface is a program that allows the user to control the functions of the operating system. Two user interfaces that we'll discuss are the Graphical User Interface, or GUI, and the Command Line Interface, or CLI. Let's cover these interfaces in more detail. A GUI is a user interface that uses icons on the screen to manage different tasks on the computer. Most operating systems can be used with a graphical user interface. If you've used a personal computer or a cell phone, you have experience operating a GUI. Most GUIs include these components: a start menu with program groups, a taskbar for launching programs, and a desktop with icons and shortcuts. All these components help you communicate with the OS to execute tasks. In addition to clicking on icons, when you use a GUI, you can also search for files or applications from the start menu. You just have to remember the icon or name of the program to activate an application. Now let's discuss the command line interface. In comparison, the command line interface, or CLI, is a text-based user interface that uses commands to interact with the computer. These commands communicate with the operating system and execute tasks like opening programs. The command line interface is a much different structure than the graphical user interface. When you use a CLI, you'll immediately notice a difference. There are no icons or graphics on the screen. The command line interface looks similar to lines of code used in certain text languages. A CLI is more flexible and more powerful than a GUI. Think about using a CLI like creating whatever meal you'd like from ingredient spot at a grocery store. This gives you a lot of control and customization about what you're going to eat. In comparison, using a GUI is more like ordering food from a restaurant. You can only order what's on the menu. If you want both a noodle dish and pizza, but the first restaurant you go to only has pizza, you'll have to go to another restaurant to order the noodles. With a graphical user interface, you must do one task at a time. But the command line interface allows for customization, which lets you complete multiple tasks simultaneously. For example, imagine you have a folder with hundreds of files of different file types, and you need to move only the JPEG files to a new folder. Think about how slow and tedious this would be as you use the GUI to find each JPEG file in this folder and move it into the new one. On the other hand, the CLI would allow you to streamline this process and move them all at once. As you can see, there are very big differences in these two types of user interfaces. As a security analyst, some of your work may involve command line interface. When analyzing logs or authenticating and authorizing users, security analysts commonly use a CLI in their everyday work. In this video, we discuss two types of user interfaces. You learn that you already have experience using a graphical user interface, as most personal computers and cell phones use a GUI. And you were introduced to the command line interface. Later in the program, you'll learn how to use a CLI in Linux and how relevant it is to your daily work as a security analyst. You'll get practical experience communicating through the command line. Pretty exciting, right? We did it. What a great section of learning. The best thing is that we did this together and covered some very useful topics. Let's recap this section's lessons. As a security analyst, it's important that you understand the systems that you're working with. Understanding computer basics will help you do your job more effectively and efficiently. In this section, we covered common operating systems. We also discussed the main functions of an operating system. Importantly, you learn about the relationship between operating systems, applications, and hardware. It was nice to learn how they flow together like an orchestra. In addition, you learn about the differences between the graphical user interface and the command line interface. Understanding the command line interface will be very important for your work. I enjoyed exploring the world of operating systems with you. Knowing how operating systems work is an important step in preparing for a position as a security analyst. You're doing great. Let's keep moving forward with this program. In the next section, we'll focus specifically on the Linux operating system. Welcome back. We have another important topic to explore. Previously, you learned about operating systems and user interfaces. You learned how operating systems work and how resources are allocated in computers. We also reviewed several common operating systems. You may already have a favorite operating system. It's common to hear that people are fans of one over another. But in the security world, Linux is commonly used. In this section, together, Torvald and Stallman's innovations made what is commonly referred to as Linux. Now that you've learned the history behind Linux, let's take a look at what makes Linux unique. As mentioned before, Linux is open source, meaning anyone can have access to the operating system and the source code. Linux and many of the programs that come with Linux are licensed under the terms of the GNU Public License, which allow you to use, share, and modify them freely. Thanks to Linux's open source philosophy, as well as its strong feature set, an entire community of developers has adopted this operating system. These developers are able to collaborate on projects and advance computing together. As a security analyst, you'll discover that Linux is used at different organizations. More specifically, Linux is used in many security programs. Another unique feature about Linux is the different distributions for a variety of different development. Because of the large community contribution, there are over 600 distributions of Linux. Later, you'll learn more about distributions. Finally, let's take a look at how you use Linux in an entry-level security position. As a security analyst, you'll use many tools and programs in everyday work. You might examine different types of logs to identify what's going on in a system. For example, you might find yourself looking at an error log when investigating an issue. Another place where you will use Linux is to verify access and authorization. In security, managing access is key in order to ensure a secure system. We'll take a closer look into access and authorization later. Finally, as an analyst, you might find yourself working with specific distributions designed for a particular task. For example, you might use a distribution that has a digital forensic tool to investigate what happened in an event alert. You might also use a distribution that's for pen testing and offensive security to look for vulnerabilities in the system. Distributions are created to fit the needs of their users. I hope you're excited to learn more about Linux. This will be a very useful skill in the security field. Let me start with a quick question that may seem unrelated to security. Do you have a favorite building? And what is it about its architecture that impresses you the most? The windows? The structure of the walls? Just like buildings, operating systems also have an architecture and are made up of discrete components that work together to form the whole. In this video, we're going to look at all the components that together make up Linux. The components of Linux include the user, applications, the shell, the file system hierarchy standard, the kernel, and the hardware. Don't worry, we'll go into these components one by one together. First, you're the user. The user is the person interacting with the computer. In Linux, you're the first element to the architecture of the operating system. You're initiating the tasks or commands that the OS is going to execute. Linux is a multi-user system. This means that more than one user can use the system's resources at the same time. The second element of the architecture is the applications within a system. An application is a program that performs a specific task, such as a word processor or a calculator. You might hear the word application and programs used interchangeably. As an example, one popular Linux application that we'll learn more about later is Nano. Nano is a text editor. This simple application helps you keep notes on the screen. Linux applications are commonly distributed through package managers. We'll learn more about this process later. The next component in the architecture of Linux is the shell. This is an important element because it is how you will communicate with the system. The shell is a command line interpreter. It processes commands and outputs the results. This might sound familiar. Previously, we learned about the two types of user interfaces, the GUI and the CLI. You can think of the shell as a CLI. Another element of the architecture of Linux is the File System Hierarchy Standard, or FHS. It's the component of the Linux OS that organizes data. An easy way for you to think about the FHS is to think about it as a filing cabinet. FHS is how data is stored in a system. It's a way to organize data so that it can be found when the data is accessed by the system. That brings us to the kernel. The kernel is a component of the Linux OS that manages processes and memory. The kernel communicates with the hardware to execute the commands sent by the shell. The kernel uses drivers to enable applications to execute tasks. The Linux kernel helps ensure that the system allocates resources more efficiently and makes the system work faster. Finally, the last component of the architecture is the hardware. Hardware refers to the physical components of a computer. You can compare this to software applications, which can be downloaded into a system. The hardware in your computer are things like the CPU, mouse, and keyboard. Congratulations! We've now covered the architecture of Linux. An understanding of these components will help you become increasingly familiar with Linux. Let's learn a little bit more about Linux and what you need to know about this operating system when working as a security analyst. Linux is a very customizable operating system. Unlike other operating systems, there are different versions available for you to use. These different versions of Linux are called distributions. You might also hear them called distros or flavors of Linux. It's essential for you to understand the distribution that you're using, so you know what tools and apps are available to you. For example, Debian is a distro that has different tools than the Ubuntu distribution. Let's use an analogy to describe Linux distributions. Think of the OS as a vehicle. First, we'll start with its engine. That would be the kernel. Just as the engine makes the vehicle run, the kernel is the most important component of the Linux OS. Because the Linux kernel is open source, anyone can take the kernel and modify it to build a new distribution. This is comparable to a vehicle manufacturer taking an engine and creating different types of vehicles: trucks, cars, vans, convertibles, buses, airplanes, and so on. These different types of vehicles can be compared to different Linux distributions. A bus is used to transport lots of people. A truck is used to transport a large number of goods across vast distances. An aircraft transports passengers or goods by air. Just as each vehicle serves its own purpose, different distributions are used for different reasons. Additionally, vehicles all have different components which distinguish them from each other. Aircrafts have control panels with buttons and knobs. Regular cars have 4 tires, but trucks can have more. Similarly, different Linux distributions contain different pre-installed programs, user interfaces, and much more. A lot of this is based on what the Linux user needs, but some distros are also chosen based on preference. the same way a sports car might be chosen
Sou pa
as
ta
a
vle fè nou
vehicle.
nan, ou ta vle voye
The
li ale
advantage of
direkte
using
bo pa
Linux
pa
as an
sa li,
OS
magè
is
ta
that
ba
you
mè
can
pas si
customize
li
it.
pendant
Distributions
okay?
include the Linux
Sa gen
kernel,
3 etap la
utilities,
ke
a
nou bezwen
package
nou
management
asye ke nou men
system,
pou ke nou
and an
kapab
installer. We learned earlier that Linux is open source, and anyone can contribute to adding to the source code.
Please,
That is how new distributions are created. All distros are
following
derived from another
statement
distro,
and
but there are a
select
few that are
any
considered parent
that
distributions.
apply for
Red
you.
Hat is a parent of
Nan
CentOS,
kat sa ou ba la,
and
ou pal
Slackware is the
gade pou e
parent of
ki
SUSE.
yes
Both
condition
Ubuntu
pou la
and Kali
ye.
Linux are derived from Debian. As we
Yo
continue,
desko
we're
aksyon
going to
nan
take a
go
look at some of the
prosesi
distributions
imigrasyon
most
nan
commonly
kote
used by security
avan ke
analysts.
ou
The more you
komanse
understand these
papye sa.
distributions, the easier your work will
Ok?
be.
E se son moun ki te deja aplike pou bagay sa
In
deja,
this
ou kon
section,
prosesi
we're going to
pou
cover a
prosesi nan
Linux
kote deja
distribution
wazen.
that's widely
E
used in security and discuss Kali
okay?
Linux.
If you are
Kali
sou son ti
Linux
moun,
is a trademark
ki
of
bez
offensive
proteksyon ba wap
security
apelay
and
bagay,
is
wala di ba
Debian
an form yo
derived.
kon form yo bay pou
This
yo.
open source
Okay?
distro was
Ki
made
diferan
specifically
avek
with
form
penetration
wala la,
testing
okay?
and digital forensics in mind. There are
Se te gen
many
lota
tools
aplikasyon ki te
pre-installed
deja
into Kali Linux.
deja
It's important
fet
to note
deja
that Kali
pou
Linux should
imigrasyon,
be
okay,
used on a virtual machine.
wap chwazi,
This prevents
wap chwazi
damage
sa,
to your
okay?
system in
So,
the event
I
its
have
tools are used improperly.
already submit
An additional
my form,
benefit is that
still
using a virtual
pending
machine
before arrest,
gives you
okay?
the ability
So,
to
te deja
revert to a
vou
previous
deja,
state.
okay? Se ou
As security professionals advance in their careers, some specialize in penetration testing. A penetration test is a simulated attack that helps identify vulnerabilities in systems, networks, websites, applications, and processes. Kali Linux has numerous tools that are useful during penetration testing. Let's look at a few examples. To begin, Metasploit can be used to look for and exploit vulnerabilities on machines. Burp Suite is another tool that helps to test for weaknesses in web applications. And finally, John the Ripper is a tool used against passwords. As a security analyst, your work might involve digital forensics. Digital forensics is the practice of collecting and analyzing data to determine what has happened after an attack. For example, you might take an investigative look at data related to a network activity. Kali Linux is also a useful distribution for security professionals who are involved in digital forensic work. It has a large number of tools that can be used for this. As one example, TCP dump is a command line packet analyzer. It's used to capture network traffic. Another tool commonly used in the security profession is Wireshark. It has a graphical user interface that can be used to analyze live and capture network traffic. And as a final example, Autopsy is a forensic tool used to analyze hard drives and smartphones. These are just a few tools included with Kali Linux. This distribution has many tools used to conduct pen testing and digital forensics. We've explored how Kali Linux is an important distribution that's widely used in security, but there are other distributions that security professionals use as well. Next, we'll explore a few more distributions. Welcome back. In this video, we're going to discuss the Linux shell. This part of the Linux architecture is where the action will happen for you as a security analyst. We introduced the shell with other components of the Linux OS earlier, but let's take a deeper look at what the shell is and what it does. The shell is a command line interpreter. That means it helps you communicate with the operating system through the command line. Previously, we discussed a command line interface. This is essentially the shell provides the command line interface for you to interact with the OS. To tell the OS what to do, you enter the commands into this interface. A command is an instruction telling the computer to do something. The shell communicates with the kernel to execute these commands. Earlier, we discussed how the operating system helps humans and computers speak with each other. The shell is part of the OS that allows you to do this. Think of this as a very helpful language interpreter between you and your system. Since you do not speak computer language or binary, you can't directly communicate with your system. This is where the shell comes in to help you. Your OS doesn't need the shell for most of its work, but it is an interface between you and what your system can offer. It allows you to perform math, run tests, and execute applications. More importantly, it allows you to combine these operations and connect applications to each other to perform complex and automated tasks. Just as there are many Linux distributions, there are many different types of shells. We'll primarily focus on the bash shell in this course. Let's continue to learn more about the shell. Hello again.
Okay.
In this video, we're going to learn a little more about the shell and how to communicate with it. Communicating with a computer is like having a conversation with your friend. One person asks a question and the other person answers with a response. If you don't know the answer, you can just say you don't know the answer. When you communicate with the shell, the commands in the shell can take input, give output, or give error messages. Let's explore standard input, standard output, and the error messages in more detail. Standard input consists of information received by the OS via the command line. This is like you asking your friend a question during a conversation. The information is input from your keyboard to the shell. If the shell can interpret your requests, it asks the kernel for the resources it needs to execute the related task. Let's take a look at this to echo, a Linux command that outputs a specified string of text. String data is data consisting of an order sequence of characters. In our example, we'll just have it output the string of hello. So as input, we'll type echo hello into the shell. Later, when we press enter, we'll get the output. But before we do that, let's first discuss the concept of output in more detail. Standard output is the information returned by the OS through the shell. In the same way that your friend gives an answer to your question, output is a computer's response to the command you input. Output is what you receive. Let's pick up where we left off in our example and send the input of echo hello to the OS by pressing enter. Immediately, the shell returns the output of hello. Finally, standard error contains error messages returned by the OS through the shell. Just like your friend might indicate that they can't answer a question, the system responds with an error message if they can't respond to your command. Sometimes this might occur when we misspell a command or the system doesn't know the response to the command. Other times, it might happen because we don't have the appropriate permissions to perform a command. We'll explore another example that demonstrates standard error. Let's input echo hello into the shell. Notice I intentionally misspelled echo as ECO. When we press enter, an error message appears. To wrap up, we've covered the basics of communication with the shell. Communication with the shell can only go in one of three ways. The system receives a command. This is input. The system responds to the command and produces output. And finally, the system doesn't know how to respond, resulting in an error. Later, you'll become much more familiar with this as we explore commands useful for security professionals. We've made it to the end of this section. Great work. Let's recap what you've just completed. In this section, you learned about the Linux operating system. We examined the architecture of Linux. In our exploration of the different distributions of Linux, we discussed some of the most widely used distros in security. You were introduced to Kali Linux, Ubuntu, Parrot, Red Hat, and CentOS distributions. Finally, you learned about the shell and its role as an interpreter between the user and operating system. Congratulations! You're doing great, and we have more useful topics to come. In the next part of the program, you'll learn specific commands to use within the shell while working as a security analyst. Let's continue on. Learning to communicate in a new way can be exciting. Maybe you've learned a new language and can remember this feeling. Perhaps a lot of us share this excitement with young children as they are expanding their vocabulary. Others, including me, remember a sense of wonder when we first used a specialized language to communicate with a computer. In this section, we'll continue to learn more about Linux and how to communicate with the OS through its shell. You'll utilize the command line to communicate with the OS. You'll learn how to input commands in the shell and learn about some of the core Linux commands that you'll use as a security analyst. Specifically, this includes navigating and managing the file system. You'll also focus on authenticating and authorizing users. This means you'll be able to use a command line to add and delete users from the system and to control what they have access to. Finally, there's always more to learn. So we'll cover accessing resources that support learning new Linux commands. I remember when I first learned about the command line and was shocked at the capabilities it provided. I didn't need to click through multiple
parce que
screens
bon
to get
nous
tasks
sont pas
done.
un affaire qui pas vrai,
Although it
OK,
took
ça
some
n'a fait là il
practice
pas vrai.
and time to get used
OK.
to, it has been one of the biggest tools at my disposal. After this section, you'll have a practical experience in an area important to the work of a security analyst, using Linux commands. Welcome back.
OK, Jean-Pierre.
Before we get into specific Linux commands, let's explore in more detail the basics of communicating with the OS. Being able to utilize Linux commands is a foundational skill for all security professionals. As a security analyst, you'll work with server logs and you'll need to know how to navigate, manage, and analyze files remotely without a graphical user interface. In addition, you'll need to know how to verify and configure users and group access. You'll also need to give authorization and set file permissions. That means that developing skills with the command line is essential for your work as a security analyst. When we learned about the Linux architecture, we learned that the shell is one of the main components of the operating system. We also learned that there are different shells. In this section, we'll utilize the bash shell. Bash is the default shell in most Linux distributions. For the most part, the key Linux commands that you'll be learning in this section are the same across shells. Now that you know what shell you'll be using, let's go into how to write in bash. As we discussed in the previous section, communicating with your OS is like a conversation. You type in commands and the OS responds with an answer to your command. A command is an instruction telling the computer to do something. We'll try out a command in bash. Notice a $sign before the cursor. This is your prompt to enter a new command. Some commands might tell the computer to find something like a specific file. Others might tell it to launch a program, or it might be to output a specific string of text. In the last section, when we discussed input and output, we explored how the echo command did this. Let's input the echo command again. You may notice that the command we just input is not complete. If we're going to use the echo command to output a specific string of text, we need to specify what the string of text is. This is what arguments are for. An argument is specific information needed by a command. Some commands take multiple arguments. So now, let's complete the echo command with an argument. We're learning some pretty technical stuff, so how about we output the words, "You are doing great." We'll add this argument, and then we'll press enter to get the output. In this example, our argument was a string of text. Arguments can provide other types of information as well. One thing that is really important in Linux is that all commands and arguments are case sensitive. This includes file and directory names. Keep that in mind as you learn more about how to use Linux in your day-to-day tasks as a security analyst. Okay, now that we've covered the basics of entering Linux commands and arguments through the bash shell, we're ready to learn some specific commands. This is exciting, so let's get to our next video. Welcome back. I hope you're learning a lot about how to communicate with the Linux OS. As we continue our journey into utilizing the Linux command line, we'll focus on how to navigate the Linux file system. Now, I want you to imagine a tree. What did you notice first about the tree? Would you say the trunk or the branches? These might definitely get your attention, but what about its roots? Everything about a tree starts in the roots. Something similar happens when we think about the Linux file system. Previously, we learned about the components of the Linux architecture. The File System Hierarchy Standard, or FHS, is the component of the Linux OS that organizes data. This file system is a very important part of Linux because everything we do in Linux is considered a file somewhere in the system's directory. The FHS is a hierarchical system, and just like with a tree, everything grows and branches out from the root. The root directory is the highest level directory in Linux. It's designated by a single slash. Subdirectories branch out from the root directory. The subdirectories branch out further and further away from the root directory. When describing the directory structure in Linux, slashes are used when tracing back through these branches to the root. For example, here, the first slash indicates the root directory. Then it branches out a level into the home subdirectory. Another slash indicates it is branching out again. This time, it's to the analyst subdirectory that is located within home. When working in security, it is essential that you learn to navigate a file system to locate and analyze logs, such as log files. You'll analyze these log files for application usage and authentication. With that background, we're now ready to learn the commands commonly used for navigating the file system. First, pwd prints the working directory onto the screen. When you use this command, the output tells you which directory you're currently in. Next, ls displays the names of files and directories in the current working directory. And finally, cd navigates between directories. This is the command you'll use when you want to change directories. Let's use these commands in Bash. First, we'll type the command pwd to display the current location and then press enter. The output is the path to the analyst directory, where we're currently working. Next, let's input ls to display the files and directories within the analyst directory. The output is the name of 4 directories: logs, old reports, projects, and reports, and one file named updates.txt. So let's say we now want to go into the logs directory to check for unauthorized access. We'll input cd logs to change directories. We won't get any output on the screen from the cd command, but if we enter pwd again, its output indicates the working directory is logs. Logs is a subdirectory of the analyst directory. As a security analyst, you'll also need to know how to read file content in Linux. For example, you may need to read files that contain configuration settings to identify potential vulnerabilities. Or you might look at user access reports while investigating unauthorized access. When reading file content, there are some commands that will help you. First, cat displays the content of a file. This is useful, but sometimes you won't want the full contents of a large file. In these cases, you can use the head command. It displays just the beginning of a file, by default 10 lines. Let's try out these commands. Imagine that we want to read the contents of access.txt, and we're already in the working directory, where it's located. First, we input the cat command and then follow it with the name of the file, access.txt. And Bash returns the full contents of this file. Let's compare that to the head command. When we input the head command followed by our file name, only the first 10 lines of this file are displayed. Wow! This section had lots of action, and it's just the beginning. I'm glad you learned how security analysts can use essential commands to navigate the system. Next, we'll explore how to manage the system. Now that we covered pwd, ls, and cd, and are familiar with these basic commands for navigating the Linux file system, let's look at a couple of ways to find what you need within this system. As a security analyst, your work will likely involve filtering for the information you need. Filtering means searching your system for specific information that can help you solve complex problems. For example, imagine that your team determines a piece of malware contains a string of characters. You might be tasked with finding other files with the same string to determine if those files contain the same malware. Later, we'll learn more about how you can use SQL to filter a database, but Linux is a good place to start basic filtering. First, we'll start with grep. The grep command searches a specified file and returns all lines in the file containing a specified string. Here's an example of this. Let's say we have a file called updates.txt, and we're currently looking for lines that contain the word OS. If the file is large, it would take a long time to visually scan for this. Instead, after navigating to the directory that contains updates.txt, we'll type the command grep os updates.txt into the shell. Notice how the grep command is followed by 2 arguments. The first argument is the string we're searching for, in this case, OS. The second argument is the name of the file we're searching through, updates.txt. When we press enter, Bash returns all lines containing the word OS. Now, let's talk about piping. Piping is a Linux command that can be used for a variety of purposes. In a moment, we'll focus on how it can be used for filtering. But first, let's talk about the general idea of piping. The piping command sends a standard output of one command as standard input into another command for further processing. It's represented by the vertical bar character. In our context, we can refer to this as the pipe character. Take a moment and imagine a physical pipe. Physical pipes have two ends. On one end, for example, water might enter the pipe from a hot water tank. Then, it travels through the pipe and comes out on the other end in a sink. Similarly, in Linux, piping also involves redirection. Output from one command is sent through the pipe and then is used on the other side of the pipe. Earlier in this video, I explained how grep can be used to filter for strings of characters within a file. Grep can also be incorporated after a pipe. Let's focus on this example. The first command, ls, instructs the operating system to output the file and directory contents of the report's subdirectory. But because the command is followed by the pipe, the output isn't returned to the screen. Instead, it's sent to the next command. As we just learned, grep searches for a specified string of characters. In this case, it's users. But where is it searching? Since grep follows a pipe, the output of the previous command indicates where to search. In this case, that output is a list of files and directories within the report's subdirectory. It will return all files and directories that contain the word users. Okay, let's explore this in Bash. So we can better understand how the filter works, let's first output everything in the reports directory. If we were already in the directory, we would just need to input ls. But since we're not, we'll also specify the path to this directory. When we press enter, the output indicates there are 7 files in the reports directory. Because we want to return only the files that contain the word users, we'll combine this ls command with piping and the grep command. As the output demonstrates, Linux has been instructed to return only files that contain the word users. The 2 files that don't contain this string no longer appear. So now you have 2 different ways that you can filter in Linux while working as an analyst. Navigating through files and filtering are just part of what you need to know. Let's keep exploring the Linux command line. Let's make some branches. What do I mean by that? Well, in a previous video, we discussed root directories and how other subdirectories branch off of the root directory. Let's think again about the file directory system as a tree. The subdirectories are the branches of the tree. They are all connected from the same root, but can grow to make a complex tree. In this video, we'll create directories and files and learn how to modify them. When it comes to working with data and security, organization is key. If we know where information is located, it makes it easier to detect issues and keep information safe. In a previous video, we've already discussed navigating between directories, but let's take a moment to examine directories more closely. It's possible you're familiar with the concept of folders for organizing information. In Linux, we have directories. Directories help organize files and subdirectories. For example, within a directory for reports, an analyst may need to create 2 subdirectories, one for drafts and one for final reports. Now that we know why we need directories, let's take a look at some essential Linux commands for managing directories and files. First, let's take note of commands for creating and removing directories. The mkdir command creates a new directory. In contrast, rmdir removes or deletes a directory. A helpful feature of this command is its built-in warning that lets you know a directory is not empty. This saves you from accidentally deleting files. Next, you'll use other commands for creating and removing files. The touch command creates a new file, and then the rm command removes or deletes a file. And last, we have our commands for copying and moving files or directories. The mv command moves a file or directory to a new location, and cp copies a file or directory into a new location. Okay, now we're ready to try out these commands. First, let's use the pwd command. And then let's display the names of the files and directories in the analyst directory with the ls command. Imagine that we no longer need the old reports directory that appears among the file contents. Let's take a look at how to remove it. We input the rmdir command and follow it with the name of the directory we want to remove, all reports. We can use the ls command to confirm that all reports has been deleted and no longer appears among the contents. Now, let's make another change. We want a new directory for drafts of reports. So we need to use the command mkdir and specify a name for this directory, drafts. If we input ls again, we'll notice the new directory drafts included among the contents of the analyst directory. Let's change into this new directory by entering cd drafts. If we run ls, it doesn't return any output, indicating that this directory is currently empty. But next, we'll add some files to it. Let's say we want to draft new reports on recently installed email and OS patches. To create these files, we input touch email _patches.txt and then touch os _patches.txt. Running ls indicates that these files are now in the drafts directory. What if we realize that we only need a new report on OS patches and we want to delete the email patches report? To do this, we input the rm command and specify the file to delete as email _patches.txt. Running ls confirms that it's been deleted. Now, let's focus on our commands for moving and copying. We realize that we have a file called email policy in the reports folder that is currently in draft format. So we want to move it into the newly created drafts folder. To do this, we need to change into the directory that currently has that file. Running ls in that directory indicates that it contains several files, including email _policy.txt. Then to move that file, we'll enter the mv command followed by two arguments. The first argument after mv identifies a file to be moved. The second argument indicates where to move it. If we change directories into drafts and then display its contents, we'll notice that the email policy file has been moved to this directory. We'll change back into reports. Displaying the file contents confirms that email _policy is no longer there. Okay, one more thing. Vulnerabilities.txt is a file that we want to keep in the reports directory. But since it affects an upcoming project, we also want to copy it into the projects directory. Since we're already in the directory that has this file, we'll use the cp command to copy it into the projects directory. Notice that the first argument indicates which file to copy, and the second argument provides the path to the directory that it will be copied into. When we press enter, this copies the vulnerabilities file into the projects directory, while also leaving the original within reports. Isn't it cool what we can do with these commands? Now let's focus on one more concept related to modifying files. In addition to using commands, you can also use applications to help you edit files. As a security analyst, file editors are often necessary for your daily tasks like writing or editing reports. A popular file editor is Nano. It's good for beginners. You can access this tool through the Nano command. Let's get familiar with Nano together. We'll add a title to our new draft report, os _patches.txt. First, we change into the directory containing that file. Then, we input Nano, followed by the name of the file we want to edit, os _patches.txt. This brings up the Nano file editor with that file open. For now, we'll just enter the title OS Patches by typing this into the editor. We need to save this before returning to the command line, and to do so, we press Ctrl O, and then Enter to save it with the current file name. Then
Okay.
to exit, we
Si
press
vous signalez
Control
nebe
X.
ba ali nebe sil bagen tou, ou just di ou ili bagen, okay?
Great work.
Et puis what
We've
is your
covered a
shield
lot of
passport
topics
number?
here,
Si
from
li
creating and
passport, ou
removing
bali sil bagen
directories
tou,
and
ou
files,
zil
to
bagen.
copying or moving
Okay?
them,
What
and
is your
just now,
social
we've
security?
added
Si li
editing
ou mette sil
files.
bagen tou,
You're
si
well on your way
depuis
to
nou
learning
fet
Linux
isi
commands.
t'Etats-Unis, premier jour l fè la, tou gen social, c'est ça gen.
Hi there.
Ça gen, ça
It's great to
ka
have you
bataille.
back.
Il tou gen social,
Let's
tou rezidans
continue to
depuis
learn
jour
more
fet.
about
Depuis
how
jour
to
fet
work
la.
in Linux as a security analyst.
Et puis,
In this video,
next.
we'll explore file and directory permissions.
Et pour
We'll learn how
add,
Linux represents
if you have
permissions and how you can check for the permissions
so
associated with files and directories. Permissions are the type of access granted for a file or directory. Permissions are related to authorization. Authorization is the concept of granting access to specific resources in a system. Authorization allows you to limit access to specified files or directories. A good rule to follow is that data access is on a need-to-know basis. You could imagine the security risk it would impose if anyone could access or modify anything they wanted to on a system. There are 3 types of permissions in Linux that an authorized user can have. The first type of permission is read. On a file, read permissions means contents on the file can be read. On a directory, this permission means you can read all files in that directory. Next are write permissions. Write permissions on a file allow modifications of contents of the file. On a directory, write permissions indicate that new files can be created in that directory. Finally, there are also execute permissions. Execute permissions on files mean that the file can be executed if it's an executable file. Execute permissions on directories allow users to enter into a directory and access its files. Permissions are granted for 3 different types of owners. The first type is the user. The user is the owner of the file. When you create a file, you become the owner of the file, but the ownership can be changed.
What is your model name?
Group is the next type. Every user is a part of a certain group. A group consists of several users, and this is one way to manage a multi-user environment. Finally, there is other. Other can be considered all other users on the system. Basically, anyone else with access to the system belongs to this group.
What is your model CD?
In Linux, file permissions are represented with a 10-character string. For a directory with full permissions for the user group, this string would be D, RWX, RWX, RWX. Let's examine what this means more closely. The first character indicates the file type. As shown in this example, D is used to indicate it is a directory. If this character contained a hyphen instead, it would be a regular file. The second, third, and fourth characters indicate the permissions for the user. In this example, R indicates the user has read permissions. W indicates the user has write permissions. And X indicates the user has execute permissions. If one of these permissions was missing, there would be a hyphen instead of the letter. In the same way, the 5th, 6th, and 7th characters indicate permissions for the next owner type group. As it shows here, the type group also has read, write, and execute permissions. There are no hyphens to indicate that any of these permissions haven't been granted. Finally, the 8th through 10th characters indicate permissions for the last owner type, other. They also have read, write, and execute permissions in this example. Ensuring files and directories are set with their appropriate access permissions is critical to protecting sensitive files and maintaining the overall security of a system. For example, payroll departments handle sensitive information. If someone outside of the payroll group could read this file, this would be a privacy concern. Another example is when the user, the group, and other can all write to a file. This type of file is considered a world writable file. World writable files can pose significant security risks. So how do we check permissions? First, we need to understand what options are. Options modify the behavior of the command. The options for a command can be a single letter or a full word. Checking permissions involves adding options to the ls command. First, ls-l displays permissions to files and directories. You might also want to display hidden files and identify their permissions. Hidden files, which begin with a period before their name, don't normally appear when you use ls to display file contents. Entering ls-a displays hidden files. Then, you can combine these two options to do both. Entering ls-la displays permissions to files and directories, including hidden files. Let's get into Bash and try out these options. Right now, we're in the project subdirectory. First, let's use the ls command to display its contents. The output displays the files in this directory, but we don't know anything about their permissions. By using ls-l instead, we get expanded information on these files. Let's do this. The file names are now on the right side of each row. The first piece of information in each row shows the permissions in the format that we discussed earlier. Since these are all files and not directories, notice how the first character is a hyphen. Let's focus on one specific file, project1.txt. The second through fourth characters of its permissions show us the user has both read and write permissions, but lacks execute permissions. In both the 5th through 7th characters and 8th through 10th characters, the sequence is R-. This means group and other have only read privileges. After the permissions, ls-l first displays the username. Here, that's us, analyst. Next comes the group name, in our case, the security group. Now let's use ls-a. The output includes two more files, hidden files with the names .hidden1.txt and .hidden2.txt. Finally, we can also use ls-la to show the permissions for all files, including these hidden files. I thought that was pretty interesting. Did you? You now know a little more about file permissions and ownership. This will be helpful when working in security, because monitoring and setting correct permissions is essential for protecting information. Take a small break and meet me in the next video. Hi there. In the previous video, you learned how to check permissions for a user. In this video, we're going to learn about changing permissions. When working as a security analyst, there may be many reasons to change permissions for a user. A user may have changed departments or been assigned to a different work group. A user might simply no longer be working on a project that requires certain permissions. These changes are necessary in order to protect system files from being accidentally or deliberately altered or deleted. Let's explore a related command that helps control this access. In this video, we'll learn about chmod. Chmod changes permissions on files and directories. The command chmod stands for change mode. There are two modes for changing permissions, but we'll focus on symbolic. The best way to learn about how chmod works is through an example. I know this has a lot of details, but we'll break this down. Also, please keep in mind that, like many Linux commands, you don't have to memorize the information. You can always find a reference. With chmod, you need to identify which file or directory you want to adjust permissions for. This is the final argument, in this case a file named access.txt. The first argument, added directly after the chmod command, indicates how to change permissions. Right now, this might seem hard to interpret, but soon we'll understand why this is called symbolic mode. Previously, we learned about the three types of owners: user, group, and other. To identify these with chmod, we use U to represent the user, G to represent the group, and O to represent other. In this particular example, G indicates we will make some changes to group permissions, and O to permissions for other. These owner types are separated by a comma in this argument. But do we want to add or take away permissions? Well, for this, we use mathematical operators. So the plus sign after G means we want to add permissions for group, and the minus sign after O means we want to take them away from other. And the last question is, what kind of changes? We've already learned that R represents read permissions, W represents write permissions, and X represents execute permissions. So in this case, the W indicates that we are adding write permissions to the group, and R indicates that we are taking away read permissions from other. This is still very complex. And now that we've broken it down, perhaps it doesn't seem quite so much like a foreign language. And remember, you don't have to memorize this all. Let's give this new command a try. We'll start out in the logs subdirectory. If we use the ls-l command, it will output the permissions for the file. It shows the permissions for the only file in this directory, access.txt. Previously, we learned how to read these permissions. The second through fourth characters indicate that the user has read and write permissions. The fifth through seventh characters show the group only has read permissions. And the 8th through 10th characters show that other only has read permissions. We need to adjust these permissions. We want to ensure analysts in the security group have write permission, but take away read permissions from the owner type other. So we add write permissions for group and remove read permissions for other. Let's run ls-l again. This shows a change in the permissions for access.txt. Notice how in the middle segment of permissions for the group W has been added to give write permissions. And another change is that the R has been removed in the last segment, indicating that read permissions for other have been removed. As mentioned earlier, these hyphens indicate a lack of permissions. Now, other is lacking all permissions. Though it requires practice, working in Linux becomes more natural with time. I'm glad you're learning a little more about how to use Linux. Welcome back. In this video, we are going to discuss adding and deleting users. This is related to the concept of authentication. Authentication is the process of a user proving that they are who they say they are in the system. Just like in a physical building, not all users should be allowed in. Not all users should get access to the system. But we also want to make sure everyone who should have access to the system has it. That's why we need to add users. New users can be new to the organization or new to a group. This could be related to a change in organizational structure or simply a directive from management to move someone. And also, when users leave the organization, they need to be deleted. They should no longer have access to any part of the system. Or if they simply changed groups, they should be deleted from groups that they are no longer a part of. Now that we've sorted out why it's important to add and delete users, let's discuss a different type of user, the root user. A root user, or super user, is a user with elevated privileges to modify the system. Regular users have limitations, where the root does not. Individuals who need to perform specific tasks can be temporarily added as root users. Root users can create, modify, or delete any file and run any program. Only root users or accounts with root privileges can add new users. So you may be wondering how you become a super user. Well, one way is logging in as the root user. But running commands as the root user is considered to be bad practice when using Linux. Why is running commands as the root user potentially problematic? The first problem with logging in as root is a security risk. Malicious actors will try to breach the root account. Since it's the most powerful account, to stay safe, the root account should have logins disabled. Another problem is that it's very easy to make irreversible mistakes. It's very easy to type the wrong command in the CLI, and if you're running as the root user, you run a higher risk of making an irreversible mistake, such as permanently deleting a directory. Finally, there's the concern of accountability. In a multi-user environment like Linux, there are many users. If a user is running as root, there is no way to track who exactly ran a command. One solution to help solve this problem is sudo. Sudo is a command that temporarily grants elevated permissions to specific users. This provides more of a controlled approach compared to root, which runs every command with root privileges. Sudo solves lots of problems associated with running as root. Sudo comes from superuserdo and lets you execute commands as an elevated user without having to sign in and out of another account. Running sudo will prompt you to enter the password for the user you're currently logged in as. Not all users on a system can become a super user. Users must be granted sudo access through a configuration file called the sudoers file. Now that we've learned about sudo, let's learn how we can use it with another command to add users. This command is user add. User add adds a user to the system. Only root or users with sudo privileges can use a user add command. Let's look at a specific example in which we need to add a user. We'll imagine a new representative is joining the sales department and will be given the username of salesrep7. We're tasked with adding them to the system. Let's try adding the new user. First, we need to use the sudo command followed by the user add command. And then last, the username we want to add, in this case, salesrep7. This command doesn't display anything on the screen, but since we get a new bash cursor and not an error message, we can feel confident that the command worked successfully. If it didn't, an error message would have appeared. Sometimes an error has to do with something simple, like misspelling user add. Or it might be because we didn't have sudo privileges. Now let's learn how to do the opposite. Let's learn how to delete a user with user del. User del deletes a user from the system. Similarly, we need root permissions that we'll access through sudo to use user del. Let's go back to our example of the user we added. Let's imagine 2 months later, the sales representative we just added to the system leaves the company. That user should no longer have access to the system. Let's delete that user from the system. Again, the sudo command is used first. Then we add the user del command. Last, we add the name of the user we want to delete. Again, we know it ran successfully because there is a new bash cursor and not an error message. Now, we've covered how to add and delete users and how these actions require sudo. When using sudo, we have to use our best judgment. These special privileges must be used responsibly to ensure a secure system. There are so many others just like you who will be using the command line. Linux's popularity and ease of use has created a large online community that constantly publishes information to help users learn how to operate Linux. Since Linux is open source, it has become a global community of users that contribute frequently. This global community is a huge resource for all Linux users because users can find answers for everyday tasks. Just searching on the internet will provide many answers. The easiest way to troubleshoot a task is to search and read about how someone else has done it. Looking for resources on how to execute a task is a good way for beginners to continue learning. So far, you've learned how to add users, but imagine if later you wanted to add a new group. One way to learn how to do this is to search online. Let's give this a try through Google Search. The search results give us many options for adding a group in Linux. Another reputable source is a Unix and Linux Stack Exchange. Their answers are ranked with points to display high-quality answers. Many questions relate to more advanced users and are geared towards troubleshooting. Well, now you know where to get some extra support whenever in doubt about topics in Linux. There is a lot of support just a click away. Coming up, we'll learn how to get support from within the command line itself. Join me. Welcome back. In this video, we're going to discuss some resources that are available directly through the shell and can help you while working in Linux. One of the great things about Linux is that you can get help right through the command line. The first command that can help you in this way is man. Man displays information on other commands and how they work. The name of this command comes from the word manual. Let's examine this more closely by using man to get information about the user mod command. After man, we type the name of this command. The information that man returns includes a general description. It also contains information about each of user mod's options. For example, the option -D can be added to user mod to change a user's home directory. Command provides a lot of information, but sometimes we just need a quick reference on what a command does. In that case, you use what is. What is displays a description of a command on a single line. Let's say you heard a coworker mention a command like tail. You've never heard of this command before, but you can find out what it does. Simply use the command whatisTail and learn that it outputs the last part of files. Sometimes, we might not even know what command to look up. This is where apropos can help us. Apropos searches the manual page descriptions for a specified string. Let's try it out. Let's say you have a task that requires you to change a password, but you're not quite sure how to do this. If we use the apropos command with the string password, this will display a large number of commands with that word. This helps somewhat, but it still may be difficult to find what we need. But we can filter this by adding the -A option and an additional string. This option will return only the commands that contain both strings. In our case, since we want to change the password, let's look for commands with both change and password. Now, the output has been limited to the most relevant commands. These commands make it a lot easier to navigate the Linux command line. As a new analyst, you won't have all the answers all the time, but you can learn where to find them. Congratulations! You completed another section in this course. Take a minute to think about what you achieved. You learned a lot in this section. Let's recap what we covered. In this section, you utilized the command line to communicate with the OS. Part of this was using commands for navigating and managing the file system. And you use other commands for authenticating and authorizing users. These are all tasks that a security analyst is likely to encounter. Finally, you learned about accessing resources that support learning new Linux commands. With this knowledge, you'll be able to continue learning more and more about using the command line. We did it. We learned how to communicate with Linux. That's a great accomplishment, and one that will be very useful to you in your career as a security analyst. You should be proud of the work that you've done so far. In the world of security, diversity is important. Diverse perspectives are often needed to find effective solutions. This is also true of the tools we use. Your job will often require you to use a lot of diverse tools. In the last section, we studied the Linux command line and learned how this tool can help you search and filter through data, navigate through the Linux file system,